Really, this is the same as what we did for yesterday, except there's kind of the helpful little hint here. For example, let me give you an example problem. If you're doing 29 into 900, anytime you do a math problem, you should kind of take a quick look at it and try to think of some things that might help you out to be able to do this problem. For example here, I know that 29 doesn't go into 9, so there should be nothing above the 9. Okay? But when 29 goes into 90, and you're trying to figure out what number to pick to do that with, what the book is trying to help you out with this here is, as you look at this, the first thing that should maybe pop in your mind is that the number 29 is awful close to 30. And to get a good idea of how many times 29 goes into 90, you should really think about this as being 30, because it's so close to 30. It's going to give you a better number, rather than thinking about it being 20. Because if you thought about it as being 20, you'd say, well, maybe it's 4 times, but 4 is going to be way too big. So if you think about this number as being a 30, then you're going to say, Alexa, probably how many times? Probably 3. And then down here on the side, you're probably going to have to do that 3. 29 times 3 is... 3 times 9 is 27, 6, 7, 8, yeah, it's 87. So 3 is a great answer to that. And then when you subtract, you end up with another 30. And then how many times would 29 go into 30? Probably just 1 time, because it's awful close to 30 as it is. And then you have your remainder of 1. So anytime you're doing a division problem, this is probably the hardest part for most people, is trying to figure out how many times. You know, especially if you get into really big division problems, but you know, these are bad enough, but really big ones, you know, they can be a little tougher there. Nick?
This problem, wouldn't it be easier to do 30 times 3 is 90 and then minus 3?
If you like. If that works in your world, Nick, that's fine, but some of us in this world are not quite ready for that kind of estimation station. Anybody get what Nick was saying?
Yeah.
No.
So here's what he's saying. Here, take a look at this number here. Most people, if you look at a number like this, he makes a very good point, so we'll work with this here. Most people, when they look at this, they go, you know what? I don't want to do that problem because it's got a whole bunch of digits in it. But it's really, if you think about what Nick just said, he said since this number here is only one number away from 2,000, if you think about this as being 2,000, 8 times 2,000 is 16,000. But it's not 16,000 because it was only 1999. It's 1 away from that. So it's actually 1 away 8 times. So you just take 8 away from this, and that's going to be the answer as if you did this out as a multiplication, a big long multiplication problem. It'd be 15,992. Rather than you doing all that long multiplication, if you think about it, did that just go over some of your head? See, that's what I said. If it works in your world, go ahead and do it. Otherwise, just do it the way we've been doing it. Alexa.
Wait a minute. Like, where do you live?
Yes. Yeah, out of Nick's world.
So just think about it, like,
Just to get the number.
round it to the nearest 10.
Yeah, but you're not rounding it to do the problem. You're just rounding it to get the number that you need to multiply it by. Yes, that's exactly the point there. For example, 48 into 829. 48 into 829. You know, as you look at this, and you're not worried about rounding this number. You only want to think about this. Since 48 is close to 50, that's what you want to think about when you're trying to figure out how many times 48 will go into 82. You know, you think about, well, 50 will go into 82. It can't be 2 times, because 2 times 50 is 100, so that's too big. So you know it's only going to be 1 time. And then 1 times 48 is 48. You do your subtracting. You get 349. And it's much easier to think about how many times will 50 go into 349 as opposed to 48. If you think of counting by 50s, 50, 100, 150, 2, 253, 350. So your choice is either going to be 6 or 7. Which one do you think it is? Well, let's try 6. 6. Sure, let's try 6 and see if they're big enough. 48 times 6, Nick, you got that one done already? I think my 6 is too big, maybe I was thinking maybe 7 or 8. So you're gonna have to try 48 times 7, let's see what that is. 56, 5, 28, and 3 is 33. 336 looks like a good number there, so I put my 7 up there. And get my 336. And can I have 13 as a remainder? It seems awful high.
Yes.
I can't have that as a remainder as long as the remainder is the divisor. Let's use the mathematical name, the divisor. What is this number called? Dividend. And that is the quotient, divisor, dividend. Not the div at the beginning, it's the dividend. And I think that's pretty much gonna be plenty enough to get